Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I'm going to be going over how to use formal charge to determine the best Lewis dot structure and what you're looking for to do that. So there's some rules you want to follow with regard to formal charges and Lewis dot structures that will be helpful in indicating which of maybe several different Lewis dot structures for the same compound, which one or ones might be the best to choose from. First, and I mentioned this earlier in another video, that one thing you want to make sure is that the sum of the formal charges in the molecule add up to the charge or non-charge of your molecule or your ion. So if you've got a molecule and no charge, then the formal charges should all add up to 0. If you've got some sort of polyatomic ion, then all of those charges, all those formal charges should add up to the charge, the overall charge on the ion itself. So positive is positive, negative is if it's negative. The next three are rules for helping you to decide whether or not, or which of several different Lewis dot structures would be the best one, or ones. There might be more than one best. They might have be equal in their formal charges. The first one is that better structures have fewer non-zero formal charges. So if you are comparing two Lewis dot structures and you have the option of choosing one that has let's say 3 non-zero formal charges on the atoms, and in another one you count 2 non-zero formal charges, then you would go with the one that has only 2 versus the one that has three atoms that have non-zero formal charges. Okay. The one thing I want to point out with regard to Lewis dot structures and structures that are the same is that in order for two structures to be the same Lewis dot structure for a particular molecule, they should have the same conductivity. And this relates also to resonance structures, which is in another video. We're comparing structures that have the same atoms, same connections of the atoms together. So all the atoms are connected to each other in the exact same way. The only thing we're looking at is like number of bonds or like formal charges on them. And again, this is in another video. So the next rule is that better structures have smaller or 0 formal charges. So if you're comparing two structures of the same molecule, and you have one molecule where you have and they both have the same number of formal charges, so you might have 3 formal charges on this one, and then this one has 3 atoms that have formal charges, so they're equal. Then when you're comparing that, you want to look at the size of the charges themselves. So in that case, you're looking at, okay, well, which one has more 0 formal charges than the other, or which one has smaller formal charges than the other. So you're looking at that. So smaller formal charges themselves are going to be better than larger formal charges. So if you have a structure that has zeros and ones in it versus another structure that has 2s and 3s in it, then the one with the smaller formal charges is going to be the better one to go with. And the last one is better structures have the negative formal charges on the most electronegative atoms. Okay, so again, if you're comparing two structures, and let's say, for example, you've got you got oxygen and another element, let's say nitrogen. So oxygen is more electronegative than nitrogen. So if you had a choice between two structures where, again, everything is the same except for formal charges, if you have a structure that has the negative formal charge on the nitrogen versus having the negative formal charge on the oxygen, since the oxygen is more electronegative than the nitrogen, you would want the negative formal charge on the oxygen, which makes sense because, again, electronegativity has to do with the pull on the electrons, the bonded electrons in between atoms. So if one atom wants the electrons more or pulls on them more, then those electrons are going to spend more time with that atom, and so therefore giving it a partial negative charge. So you would expect more electronegative atoms to have the negative formal charge. So these are the rules for applying formal charge to your Lewis dot structures to make sure that you have the best possible structure, or at least you're able to pinpoint which of them is the more important structure. Even though all of them may be legitimate Lewis dot structures, there may be one or two that are the best to, or the most important Lewis structure that is contributing to the structure of the actual molecule. Okay, thank you for joining me. I hope you liked this video. If you liked this video, share, like, subscribe to the channel, hit the notification bell for notifications for other videos I put out. Please put a comment in the comment section. Let me know what you think, and if you have any other questions that you want me to cover. Thanks for joining me, and I'll see you next time.